Hi, it's John here, and we are moving on to the next Project Euler problem, number 6, called Sum Square Difference. And let's just go ahead and read the problem. The sum of the squares of the first 10 natural numbers is 1 squared plus 2 squared plus 10 squared equals 385. The sum of the first 10 natural numbers is 1 plus 2 plus plus 10. All of that sum squared equals 55 squared equals 3025. Hence, the difference between the sum of the squares is the first 10 natural numbers, and the square of the sum is 3025 minus 385 equals 2640. Find the difference between the sum of the squares for the first 100 natural numbers and the square of the sum. Alright, good. So we're going to start by defining the square function. Define square. It will take an argument n, and it will return the product of n and n. Alright, let's test that out. Down at the bottom we see we have it defined, so we can type square of 3. Evaluate that, and we get 9. So our square function is working. Okay, so we need to find, we're going to do summing up over a function. So let's do this. Let's say we're going to define the sum of a function. So what we're going to do is we're going to take a function coming in, and then also some sequence of numbers, what we'll call S. Okay, and what we will do is that we will reduce using the sum function, and what we'll do is we will map that function that gets passed in over the collection sequence that gets passed in. Okay, so basically what we're going to do is we're going to map that function over the sequence, and then take all those answers from that function on the sequence and add them together and return that. So if we evaluate that, then we have that done. So now we will do the sum f, and we will pass in the square function. And then also we need to pass in our collection, and let's do the range 1 through 11. Okay, let's test that out, and that gives us 385. So that says that we got the correct answer for the first part. Okay, so then the second part is to sum up all the numbers and then square the results. So basically we're going to do the same thing. We'll do the sum of the function. Now our function is kind of dumb because we're just going to return the number directly. So we're going to call the identity function, and then over that range 1 through 11. Okay, and that gives us 55, and then we need to run our square function on the result of that. So we're going to square it on the outside, and that gives us 3025. And then what we want to do is subtract we wanted to subtract this second one, or sorry, the first one from the second one, and get the result. So we can just see 3025 minus 55. Sorry. What we have is 3025 minus 385 equals 2640, and we'll just believe that works, and let's just write our whole function that could do that for us. So we'll make it a function, we'll define function, let's just call it solve. And what we'll pass in is that it will take in some n that we're going to solve to. Okay, so let's do let our sequence be the range from 1 to, and then we'll do increment n so that we get 1 through n inclusive passed into s. Okay, and then what we're going to do is we're going to subtract the square of sum f identity range, or actually now we just say s. We defined our range as s, and then we're gonna subtract sum f square and s. Okay, so that's our solve function, which basically does the whole problem. And what it says is that we didn't have everything within the scope of our let statement. So move our parenthesis over, try again. Okay, so now we have our solve function. So let's try out that with 10. So we'll run this over the first 10 natural numbers, and we get 2640 like the problem says. So that makes me believe that if we do the first 100 that we'll get the right answer. So let's try that, solve 100. And down below we get 25164,150. So let me sign in. And we'll go to number 6. Okay, so the answer that we got was that answer, and our confirmation code. Check now. And we got that one right. Great. Thank you for watching.